how to use analytical data to identify an organic compound. This is a past paper question from OCR Chemistry A, and in this question that we are going to use all the results to try to identify the organic compound. The first result was the addition of 2,4-DMP. There is no visible change. We know that this is a test for aldehydes and ketone, and no change means there is no aldehyde or ketone in our structure. No aldehydes or ketone group. And then the second data was related to the elemental analysis by mass for carbon, hydrogen, and oxygen. And we will use this data to identify or to find the empirical formula. To do that, we just need to put for each element the percentage divided by their atomic mass. So 66.63 for carbon, that will give you 5.55. And then for the hydrogen, it's 11.18 over 1. So this is 11.18. And then for the oxygen, it's 22.19 over 16. That will give you 1.39. You divide all the three numbers by the lowest one, which is 1.39. That will give you, for the carbon will be 4. For the hydrogen, it's 8. And for the oxygen, it's 1. The total of, so the empirical formula is C4, H8, and O. And the mass of the empirical formula is 72. And the third analytical data telling you that the mass spectrum, the molecular ion peak was at m over z 144. That means the molecular formula will be 2 times the empirical formula, because 72 times 2 is 144. So the molecular formula will be CaH16O2. Now we know we have 2 oxygens, we have 8 carbon and 16 hydrogen. Then the IR spectrum. In the IR spectrum, we can find this peak around 1720, and this is the peak for the carbonyl group, because when you use your data booklet, you're going to see the carbonyl group within 1680 till 1750. So this is a carbonyl group. So now we know we have a carbonyl group, but this is not aldehyde or ketone, so it can either be an acid or an ester. And when we look here, there is no broad peak for the OH, so it must be an ester. So we have an ester group. And then we have the proton NMR. The proton NMR, let's take it one by one, peak by peak, or signal by signal. So the first signal we have is the 9 protons here, which are around 0.9. So it's 0.9 as part per million. The chemical shift 0.9 part per million, and it's 9 protons, and it's a singlet. In this case, 0.9 part per million, that means carbon hydrogen that is next to a carbon. And there are 9 protons, and they are singlet, which means there is no adjacent hydrogens, and that means also that we have 3 identical 3 CH3s. So this is the first group, or the 9 hydrogens or the 9 protons that give us the peak at 0.9 part per million. The second one we have at 1.1 or 1.2 part per million. And this is the 3 protons, which are triplets. 3 protons, and they are triplets, which means this is a CH3 because they are 3 protons next to a carbon, because it's 1.1 part per million, and this carbon has 2 hydrogens. So there are 2 adjacent hydrogens, and there is 3 protons. These are the ones that give us the signal. And then we have the signal at delta 2.2 part per million. It's 2 protons, and it's quartet, which means this is usually the 2.2. This is the hydrogen, which is next to a carbonyl group. We have 2 protons here, so there are CH2 next to a carbonyl group, and there are 3 adjacent hydrogens as well. So because it's a quartet, so there are 3 adjacent hydrogens. So this is a CH2 next to a CH3 and next to a carbonyl group. And finally, the last one is this peak here or this signal at 4.1 part per million, 2 protons and singlet. So there is also the peak at 4.1 part per million. It's two protons and it's a singlet. That means this is a CH next to an oxygen because it's 4.1 part per million. There are two protons, so there are CH2, and there is no adjacent protons as well. So when you add all of this information together, you will find that your structure first start with this carbon that has the 3CH3. This is the first one. And next to it, you're going to find there is the CH2, which is next to the oxygen. This is the one at 4.1. And then we have the carbonyl group. We know we have an ester. And then there is the CH2 and then the CH3. Now we identified our structure and we used all the information. When you look at the molecular formula of this, you're going to find that this is the C8H16O2.